Hi guys, welcome back to my channel. I hope you guys are having a wonderful day. Okay, so before getting into the problem, I would request you all to please subscribe to my channel. It's been a week since I opened my YouTube channel. I've actually started with the graphical method using LPP. I have actually posted around like 9 videos before this, and 8 videos are on pure graphical method. One video is theoretical. This will be the ninth one sum wise. So mainly I have actually posted all maximization problems, and after around like posting 10 videos on maximization, I will post few more on minimization problem, because graphical method you do get quite a lot of questions based on minimization as well as maximization. In the exam you will get this kind of questions around like for 5 marks, so 5 marks is really a lot, isn't it? Okay, so let's get into the problem. Right, as you can see, I have written here, this is the objective function and these three are the constraint. So first thing which we need to do is we need to find the value of x1 and x2 for each constraint. So I have created 3 boxes, as you can see. So for the first one, that is when x1 is 0, when x1 is 0, x2 will be 4. I have written 4. Vice versa, when x2 is 0, when x2 is 0, x1 is 4. Done. Okay, for the second constraint, when x1 is 0, that is 8x2 equal to 24. So x2 will be 3. I have written that. For the opposite one, when x2 is 0, when x2 is 0, that is 3x2 equal to 24. That is x1 will be 3 8s are 24. So I've written that. Same case for the third one. After this thing, which I need to do is I need to plot the graph. Okay guys, as you can see, I have already plotted the graph, so I'm just going to explain it to you. Fine. Okay, so let's see the first coordinate. So when x1 equal to 0, x2 is 4. When this is x2 by this is x1 and this is x2. x2 is y, by the way. So when x1 equal to 0, x2 is 4, means this point. And same case for the opposite one. When x2 equal to 0, x1 is 4, means this one. See, I have joined the 2 points and I've also plotted it as 1. Actually, I've given it as numbered it as 1. That is the first constraint. Let's see for the second one. When x1 equal to 0, x2 is 3. I have written here. And when x2 equal to 0, x1 is 8. I'm sorry, something is wrong with the camera. It's not focusing properly. Sorry guys, really sorry. Okay, let's see. So when x2 equal to 0, that is when x2 equal to 0, x1 is 8. See, as you can see, so I have joined this 8 with 3. So this is constraint number 2, as I have written on both the side. And for the last one, that is when x1 equal to 0, x2 is 5, means this one. And when x2 equal to 0, x1 is 3.5, means this one. So 5 with 3.5, I have joined it. So we have got the 3 lines. Now I need to find IBFS. So this portion will be my IBFS. Why? Because first of all, the question is maximization and all the 3 constraints are in less than equal to. So less than equal to means whatever the line it has to be lesser than that. That is downward. Okay, or in inner side. Right, so for your convenience, I've actually given it as the number, that is, this is point A, since this is my IBFS, isn't it? So this is point A, this is point B. So A is 0 comma 0, B will be 3.5 comma 0. I don't know C, I have to find out. I don't know D, I need to find out. I know again E. E is my 3 comma 0, isn't it? Right, I'm sorry, E will be 0 comma 3, because this is Y, right? So I need to find the x1 and x2 for C and x1 and x2 for D. How do I need to find out? C. So this point belongs to equation number 1 and equation number 3. So I have to equate constraint 3 and constraint 1, and I will find out that from that I can get the value of x1 and x2. For D, I need to equate constraint 2 and constraint 1. So equate constraint 2 and constraint 1, you will get the value of x1 and x2 for point D. So let me just first find out the value of C. Okay guys, as you can see, I've written here for point C. That is, for point C, what are the 2 constraints which I need to formulate? That is constraint number 3 and constraint number 1. Okay, so what are the 2 equations? So as you can see, I have to formulate constraint 1 and constraint 3. Okay guys, as you can see, I have written this is constraint 1 and this is constraint 3. Let me just show you how to find out the value of x1 and x2. You will know it. This we have been taught when we were in school, isn't it? But still, let me just do it for you. Okay, so this will be 10x1 plus 10x2 equal to 40. This will be 10x1 plus 7x2 equal to 35. Okay, so this will be eliminated. This will be 3x2, this will be 5, x2 will be 5 by 3, or I can write it as 1.67. Now put the value of x2 in any one of the two equations. You will get x1 as 2.33. So for point C is done. Now I'm going to do it for point D. Okay, so for point D, we need to formulate equation number 1 and equation number 2. As you can see, so I need to formulate equation 1 and equation 2. Okay guys, as you can see, I have written here, this is equation 1 and this is equation 2. Similar manner, you need to formulate. We have got x2 as 2.4 and putting the value of x2 in any one of the two equations, you will get x1 as 1.6. So for D, the coordinates are 1.6 and 2.4. Now I have got the coordinate of point A. We know point B, we know point C. Like previously, just now we formulated point C. This is point D and point E. From the graph itself we can plot it. Now I'm going to write all the points together and I'm going to find out finally the value of Z and C, and I have to check which value of Z is bigger. Okay guys, as you can see, I have written all the coordinates, that is the IBFS coordinate, right? So for the first one, these are all x1s and these are all x2s. This is the objective function. What I need to do is simply I have to put the value of x1 in this and x2 in this. I have to do it for all. So first one, obviously this will be 0. For the second one, 3.5 into 5 is 17.5, and for C, that is 2.33 into 5 plus 7 into 1.67, we will get 23.34. Okay, so for D, that is 1.6 into 5 plus 2.4 into 7, we will get it as 24.8, and 0 into 5 is 0 and 3 into 7 is 21. So from out of 0, 17.5, 23.34, 24.8 and 21, you can see that this is the largest. My question is max D, so I have to find the maximum value. So I can write it this way, that my optimized value is 24.8, where x1 is 1.6 and x2 is 2.4. So this is my ultimate answer. Okay, thank you so much for watching. Stay tuned for the next video. In the next video, I will show the last maximization problem and then I will get into minimization. Thank you so much guys for watching. Bye bye. See you.